Hey guys, welcome back. In the last lesson, we configured and installed Kafka, and now we have a 3-node Kafka cluster to play with. In this lesson, we will try out the concepts we have learned so far in Kafka. This will help us to solidify our understanding. Sounds good? Let's get started. To try out Kafka, we need a producer who produces messages, correct? Lucky for us, Kafka out of the box has a producer named console producer. It is a simple producer to use. You start the producer and you type in whatever you like and it will be sent to Kafka. It is the simplest and easiest way to try Kafka. To consume the messages produced by the console producer, we need a consumer, correct? Again, lucky for us, Kafka out of the box comes with a consumer named console consumer. The console consumer can consume the messages from Kafka which are pushed by the console producer. So here is the setup. We'll use the console producer to produce or publish messages to Kafka. And we'll use the console consumer to consume messages from Kafka. But before we can do that, we need a topic in Kafka. So that is exactly what we'll do first. We'll create a topic named HRW console topic. Here is the command to create topic in Kafka. I will be executing this command from one of the nodes running Kafka. Also keep in mind, in our setup, Zookeeper is also running on the same nodes as Kafka brokers. But typically, Zookeeper will be running on its own node. I'll be inside the Confluent directory, so we will say bin/kafka-topics. Kafka-topics is a script. Then we say create, followed by we need to specify where Zookeeper is running. Here we don't have to specify all the nodes in the Zookeeper cluster. Just specify one running Zookeeper node and that should be fine. Zookeeper is running on the same node as Kafka, so I'm just saying localhost with port 2181. Next, we'll specify how many partitions we need for the topic and how many times we need each partition to be replicated. We'll start with one partition with replication factor of 3. So our topic will have only one partition, but will have 3 copies of that partition. Finally, we are naming the topic HRW-console-topic using the flag --topic. That is it. Let's go ahead and execute the command. Let's do a copy. I'm logged into node 1. I'm under the Confluent directory. So let's paste the command and execute. There you go. We get the message back saying create a topic HRW console topic. Now let's run a describe command on the topic HRW console topic to get more details about the topic. Let's copy this. Let's go back and execute. Here is the information about the topic HRW console topic. Our topic has only one partition, partition 0. And the leader for the partition is on node 2. And the replicas are available in 0 and 1. And 2 is the leader partition here, which is also included in the replica list. And ISR here denotes the in-sync replicas. Now, all our replicas are in sync, and hence they are in the in-sync replica list. Of course, we don't have any messages in the partition now, which means the partition is empty and both the follower replicas 0 and 1 are in sync with the leader replica 2. Hence, all 3 replicas are in the ISR list. So why don't we start both the console producer and console consumer and start sending and consuming messages. Let's start the producer first. We are invoking a script under bin named Kafka console producer. In the broker list, we have to give a list of Kafka brokers. You don't have to specify the list of all the brokers. Just give a list of few brokers and you should be fine. Producer will reach out to the broker in the list to get information about the topic, partition information behind the topic, and where the leader for each partition is hosted in the cluster. Since we have a small 3-node cluster, I have provided all 3 nodes in the broker list. Next, we need to provide the topic name where the producer will publish the messages. The topic we'll be publishing messages to is HRW console topic that we just created. Let's execute this command and start the producer on node 1. Copy and then execute. We have our producer running now. To produce a message, we just have to type the message here on the screen and it will be sent to the topic. But before we do that, let's start the consumer as well. And here's a command to start the consumer. We are invoking a script under bin named Kafka console consumer. In the dash dash bootstrap dash server, we have to give a list of Kafka brokers. In the topic, we'll provide the topic name from where we need to consume messages from. So we will provide HRW console topic. Let's execute and start the consumer on node 2. So I'm going to copy this. Node 1 is where our producer is running. So I'm going to node 2 to start our consumer. Now our consumer is running. Now we have a topic, a producer ready to publish messages to the topic, and a consumer eagerly waiting to consume messages from the topic. So let's go back to node 1 where our producer is running. And let's type in some messages. I'm going to type hello 1, hello 2, and hello 3. At this point, the console producer would have taken what we typed in and sent the 3 messages to the topic HRW console topic in Kafka. Let's go check out the consumer on node 2. And there you go. We see 3 messages that we typed in on the producer side. Now let's go back to the producer and type in more messages. Again, hello 4, hello 5, and hello 6. Let's go check the consumer now. And there you go. We see the messages published by the producer is consumed by the consumer. Great. Why don't we start another console consumer on node 3? So let's go to node 3. Let's go back to our instructions. Let's copy the console consumer command again. And let's start another consumer on node 3. There you go. Another consumer is now running on node 3. So we have 2 consumers now. One running on node 2 and another one running on node 3. Now let's go back to the producer and type in few more messages. I'm going to say hello 7, hello 8, and hello 9. Let's now check out both the consumers. I'm on node 2 now, and we see hello 7, 8, and 9. Now let's go back to node 3, and you can see the messages hello 7, 8, and 9 on the newly started consumer. You can notice that the newly started consumer is consuming only new messages. It did not consume any messages before hello 7. If we want the consumer to start consuming message from the beginning, all we have to do is enable the from beginning flag, like what you see right here. So this command is the same exact console consumer command, except we have added dash dash from beginning at the end. Let's copy this command and execute this command on a new terminal on node 3. So let me launch a new terminal on node 3. There you go, clear the screen. Let me go into the Confluent directory. Now paste the command, and this time we are starting a console consumer with the from beginning flag. And there you go. Now we got all messages from hello 1 all the way through hello 9. This also proves the point that messages are not deleted from the topic as soon as they are consumed by a consumer. Messages by default are kept in Kafka for 7 days. Now let's go back to the producer on node 1. Let's type in more messages. I'm going to say hello 10, hello 11, and hello 12. Let's now check our consumers. The consumer running on node 2, we have messages 10, 11, and 12. Same with another instance of console consumer running on node 3. We have hello 10, hello 11, and hello 12. So we see all 3 consumers are receiving the messages produced by the producer. So this is how our setup looks like now. We have added 2 more consumers, and we have a total of 3 consumers and 1 producer. And all the message produced by the producer is consumed by all 3 consumers, meaning we have 3 consumers processing the exact same messages from the producer. This is sometimes needed when each consumer is doing a different thing. Maybe one consumer is just displaying the message on the screen, and one consumer is inserting the message into a database, and one consumer is consuming the message and the message is sent to another application. But if you're planning to have multiple consumers to distribute the consumption, this is not the setup you need. If you recollect from our previous lessons, if you want to distribute the load between consumers, you would need to start consumers as part of the same consumer group. Okay, this is what we're going to do. We're going to create 2 new consumers and make them part of a consumer group. If you recollect from our previous lessons, if you want to distribute the load between consumers, you would need to start consumers as part of the same consumer group. Okay, let's do this. Let's create two new consumers and make them part of a consumer group. But before we do that, let's kill the existing consumers. I'm going to say Control C on each of our consumer just to kill them. There you go. So we have killed all three consumers. Starting consumers as part of a consumer group is very simple. Everything remains the same in the command, and at the end, add dash dash consumer property group.id and give a group name. We're giving the group name as console consumer group. Let's execute this command on node 2. We also have the from beginning flag here, so our consumer will read all the messages from the topic. So let's copy this and let's go to node 2. Let me clear the screen and execute. There we go. The consumer is now started, but it is now part of the group console consumer group, and it has processed all the messages from the topic. Let's execute the same consumer command on node 3. Let me clear the screen, copy the command, and it is started now. But now we don't see any messages consumed here. Why? Come on, think about this for a bit and try to give an answer. The reason we don't see any messages here is because Kafka knows that there is another consumer in the group which is already processing the messages from the topic. Since both consumers belong to the same group, allowing the new consumer to process the same message will result in data duplication. And that is exactly what we needed, right? We don't want duplicate data between consumers that belongs to the same group. Now let's go back to the producer and type in more messages. Let's say hello 13, hello 14, and hello 15. Now let's check both the consumers. Well, consumer 1 has hello 13, 14, and 15. Consumer 2 still has nothing. Why don't we type in more messages on the producer side? We say hello 16, hello 17, and hello 18. Let's go back and check the consumers. We got 16, 17, and 18 on consumer 1, but still nothing on consumer 2. Why do you think that is the case? Can you guess? Recollect what you have learned from the previous lessons and try to answer. So here is what is happening. We have created our topic with just one partition. And so this is how our setup looks like now. A partition can be assigned to only one consumer in a consumer group. When we started the first consumer, the partition is assigned to the first consumer. So no matter how many consumers we start, they will not be assigned to partition 1. So if we want distribution in our consumption, we need to increase the number of partitions in our topic. And here is how we can do that. We say Kafka topics alter zookeeper, give a node in the zookeeper cluster. Our zookeeper runs on every node, so we say localhost 2181. Finally, the topic name, provide the topic name HRW console topic, and then say partitions and provide the target partition number. We are increasing the number of partitions to 3 in our case here. So let's copy the command. Let me execute this on node 3. It's a cluster, so it doesn't matter where you execute. There you go. We get the message, adding partitions succeeded. Perfect. Now let's do a describe on the topic to see and make sure we have 3 partitions. So let's go back to the file. Let me copy this. There you go. Enter. As you can see, we have 3 partitions now. Partition 0, partition 1, and partition 2. The leader for partition 0 is node 2. The leader for partition 1 is node 0. And leader for partition 2 is node 1. Again, in the replica list, we have 3 including the leader. So we have one leader, the first one is the leader, and the next 2 are the followers. So for partition 0, replica on node 2 is the leader, and replicas on node 0 and 1 are the followers. And the good news is we have all 3 replicas in the ISR list for all 3 partitions. As soon as we increase the number of partitions, Kafka would kick a rebalancing operation. Now our consumer 2 will be assigned to at least one of the 3 partitions. Now let's publish more messages on the producer. Let's go to the producer. I'm going to type in more messages here. hello 19, hello 20, hello 21, hello 22, hello 23, hello 24. Now let's go back and check both consumers. Here we are in consumer 1, and you can see messages in consumer 1, but you will see some breaks in messages. Here we have messages from 1 through 19, and then you see a break. We don't see hello 20. So let's see where hello 20 went. Hello 20 went to node 3, and so is hello 23. The remaining of the messages went to consumer 1. Now we have more than one consumer in our consumer group with multiple partitions. We can effectively distribute the consumption between our consumers. We can even check which consumer is processing which partition by running this command. Here we are executing a new script, Kafka run class, and we are specifying the class we want to execute, which is kafka.admin.consumerGroup command. In the Bootstrap server, we provide the list of Kafka brokers. Finally, we say describe group, and we give the name of our consumer group, which is console consumer group. Now let's go ahead and execute this command. I'm going to execute this command on node 3. Let me clear the screen first and execute. So here is how the partition and consumer assignment looks like. Partition 0 is processed by the consumer that is running from 172.31.42.160. 172.31.42.160 is node 2. Now again, partition 1, it's also processed by the same consumer running on host 172.31.42.160. So the consumer 1 is processing two partitions, partition 0 and partition 1. The consumer running on node 3 is processing partition 2. Node 3 is 172.31.45.199. So this is consumer 2 running on node 3, which is assigned to process partition 2. You can also see the current offset, which is recorded by each consumer right here. Pretty cool, right? So here is how our setup looks like now. We have a producer and two consumers in a consumer group, dividing the three partitions amongst them and consuming the messages. Now, before we close the lesson, let's do one last thing. Why don't we kill the consumer running on host 172.31.45.199, which is node 3, and see what happens. So I'm going to node 3. I'm going to hit Control C on our consumer to kill the consumer. Now let's run the describe command on our console consumer group again to see how the partition assignments have changed. There you go. We now have only one consumer which is live assigned to all three partitions, as you can see here from the host. So the first consumer, which is running on node 2, is now assigned to process all three partitions. So as soon as we kill the second consumer, Kafka triggered a rebalancing operation and assigned partition 2 to consumer 1 as well, since consumer 2 went down. So that is it, guys. In this lesson, we experimented all the concepts that we have learned so far. We worked with multiple individual consumers and multiple consumers within one consumer group. We tried multiple consumers with one and more partitions and validated the behavior of consumption. Finally, we saw how Kafka tolerated a consumer failure. Perfect. In the next lesson, we're going to go one step further in writing our own producer and consumer. Not only that, we'll do some cool stuff. We will consume live RSVPs from meetup.com. It's going to be a very interesting couple of lessons. See you in the next lesson.